Going to do an example here about pulling something at an angle to illustrate one more aspect of normal force and so forth. So students often get the idea of the normal force incorrect, and so I want to demonstrate a couple things here. So very simple problem. We have a mass right here, okay, and let's say that the mass is 12.0 kilograms, and it's sitting on a frictionless surface, and I'm going to pull on that mass with a force of 45 newtons at an angle of 39 degrees above horizontal. So I have two questions here. What is the acceleration of this object? And secondly, what is the normal force? Okay. All right. Well, let's look at this and think about it and say, well, okay, so let's solve for the normal force first. Then we'll get back to the acceleration. So I'll make this part A of the problem and that part B of the problem. So part A of the problem, I want to find the normal force. So we have this thing. We got a free body diagram. We got mg pulling down. We got the normal force pushing up. This is at some angle theta. So we know that we have two dimensions here. We have force to the right, and we have a force that's up. Okay, and so let's just look at the up and down forces first. So we know that force the normal plus F sine theta equals mg. Okay, so what's that meaning? It means force up has to equal the force down. Okay, we're assuming we're not coming off or sinking into the surface. Okay, so that means it's staying level. Okay, and so this tells us that the normal force is going to equal mg minus F sine theta. And so the normal force is going to be equal to, well, you plug in all those numbers, and that comes out to be, given the numbers we have here, that the normal force is 89.4 newtons. Okay, now let's compare that to mg. What would mg have been? Okay, mg, mass times gravity, that would have been 118 newtons. So notice in this case, very important, okay, the normal force is not equal to mg. The normal force is not equal to mg cosine theta. Okay. The normal force is what it needs to be to keep this thing from coming off the surface. So the normal force is mg minus F sine theta. Students will frequently use either of these two options up here, and they are wrong. They will not give you the answer to this problem. So the normal force, 89.4 newtons. This becomes especially critical in chapter 6 because we introduce friction, which depends on the normal force between surfaces. Okay, so the second part of the problem here was, what's the acceleration? Okay, so now we know here we got the normal force, we got the F, angle, mg. Well, all the up forces balance all the down forces. So that means the total force y is going to be 0. So all we need to do is find the x component of the force. The x component of the force is going to be mg cosine theta. And so we look at mg cosine theta, and that's going to be ma. So a is going to be F cosine theta over m. Okay, we plug in the numbers that we have here, 45 newtons cosine 39 degrees divided by the mass 12 kilograms, and we find that the acceleration is 2.95 meter per second squared. Okay, I could go one step beyond that and say the acceleration is 2.95 meter per second squared in the I direction. And so that would be the acceleration vector in that problem.